Welcome to Maths with EJD. In the past series of videos, I've been talking about basic calculus, and in this particular module, we are talking about applications of differentiation. I've made two videos earlier. The first one was application of differentiation to kinematics, and then afterwards, I did application of differentiation to linear approximation. Now we are taking it into the realm of rate of change. Rate of change. How do we apply application? How do we apply differentiation to rate of change, the rate at which things change? And just like I always tell you, differentiation has application in almost every field of human endeavor, just because from time to time you have things changing. As time passes, things are changing. Okay, so let's look at rates of change. It is often interesting to know that the rate at which things change. For instance, you want to know the rate at which people in your house, I mean, if you are the breadwinner of the house, you want to see the rate at which people consume a bag of rice. Like, does a bag of rice finish within 4 months or 3 months or whatever? Different things like that. You want to see the rate at which your child is growing and all that in different areas. So that rate of change is something that we see in our day-to-day lives. So differentiation being all about change, right? Helps us to understand how things increase or decrease over time. Then it also facilitates our knowledge of how certain parameters change with respect to other parameters. So how do things change? How is the behavior of your child changing based on depending on the way you also behave? So things like that are questions we confront every day. Okay, so let's take our first example. Not a big deal. So, example one, the radius of a shrinking circular cell. Take note of the word circular. Circle. That's very important. The radius of a shrinking circular cell is decreasing at the rate of 5 millimeter per second. So the radius of a shrinking circular cell is decreasing at the rate of 5 millimeter per second. Find the rate at which the area is decreasing with when the radius is 17 millimeters. So you have radius shrinking, that's negative, that's decrease, and the rate is 5 millimeter per second, that's minus 5 millimeter per second because it is decreasing. And you want to find the rate at which the area is decreasing when the radius is 17 millimeters. Okay, so let's see that. So you have been given that the RDT, so the rate at which the radius is changing, is negative, it's decreasing, that's minus 5 millimeter per second. And then you have you have an information to verify when radius shrinks to 17 millimeter, when it is at 17 millimeters. So what are we looking for? We need to find the ADT, where A is the area of the cell, which can be expressed. You already know you are talking about a circle, so the area of a circle is pi r squared. Okay, so the RDT is minus 5 millimeter per second because that's the rate at which the radius is changing. Then you want to find the ADT when the radius is 17 millimeters. So what brings all this together is the fact that you're talking about a circle. So for a circular cell, the area is like pi r squared. So now you can note, it for sure that the ADT will now be dAdr. A depends on r now. So the ADT is dAdr times the RDT, because if you cancel the r, you still get your dAdT. So what you need there is the ADT. So the ADT is dAdr, which we don't have anywhere for now, multiplied by the RDT, which we have here. Okay, so now that once you're able to write this formula out, so there's no hard and fast rule about this. It depends on what you are considering. If you are told that a cylindrical cell, so you have to think of the area of a cylinder, but here it's circular, so that's why we are doing circle. So there's no general formula for this. So in this case now, the ADR can easily be found. The ADR is when you differentiate this with respect to r. So that is differentiate r squared, you get 2r times pi. That's 2 pi r. And we all know that that's the circumference of a circle, right? The circumference of a circle. So, and that's 2 pi. R is 17 now. So it means that the ADR, when r is 17 millimeter, is 34 pi millimeter. So that is settled. So we have the ADR now. We have the RDT. So it means that we can find the ADT. So the ADT is the ADR times the RDT. The ADR is 34 pi millimeter multiplied by minus 5 millimeter per second. So at the end of the day, you have 34 times 5, that's 170. So 34 pi times 5, that's 170 pi. Of course, the minus is there, millimeter squared per second. So that is the ADT. That's the rate at which the area is decreasing. Of course, for a circle now, if the radius reduces, the area will also reduce. So the area of the cell rather, is shrinking at the rate of shrinking takes care of the negative. So, or decreasing at the rate of 170 pi millimeter squared per second. So as the radius is decreasing by 5 millimeter per second, the area is decreasing by 170 pi millimeter squared per second. So that's one idea right there for you. And then we come to another example. Oh, interestingly, we have something about cylinder here. So a cylindrical tank is initially full of water. If water leaks from the base of the tank at a constant rate of 0.2 meter cube per second, cylindrical tank, take note. So find the rate of change of the depth of the water. Of course, depth of water will be like height, right? If the radius is 5.5 meters. So we are talking about a cylindrical tank, and you are talking about the base of the tank. I mean the height. So generally speaking, for a cylinder, you'll be thinking about the volume. So you've been told already that water leaks from the base of the tank at a constant rate. So the volume of water is decreasing. Basically, you need to be able to read that from the question. So it means that dV dt is minus 0.2 meter cube per second. So the volume of water is decreasing by 0.2 meter cube per second. So V now is the volume of the tank, given that V is pi r squared height. That's the formula for the area, for the volume of a cylinder. And then you want to see what happens at r equals 5.5 meters. So here we need to find the h dt, because you are told to find the rate of change of the depth. So you have a cylinder, right? You have a cylinder, and water is full of water, and water is leaking at a particular rate. And then you want to see the height the water gets to. That's like what we mean by depth. Okay, so we need to find the h dt. So dv dt from the formula, right? We are concerned with volume and height, basically. So if we had been concerned with okay, of course, there's also radius, right? So you have dv dt equals dv dh times dh dt. All right, because if you cancel this, you end up having your dv dt. But there's also radius there, right? So you can also say dv dh, that's the rate at which the volume is decreasing with respect to height. So that means if you differentiate this one with respect to h now, the h will drop off, so you have pi r squared. That's like the cross section of the cylinder, right? So you have dv dh equals pi r squared. So that's pi, the radius is 5.5 meters, 5.5 squared. And then 5.5 squared times pi is 30.25 pi meter squared. So don't forget, what we are looking for is the h dt at the end of the day. And we have the h dt here. We haven't found that, so we are still gathering information to help us find that. So let's go. So here you have dv dt equals dv dh times dh dt. And then you already know that dv dt is minus 0.2 meter cube per second. That's the rate at which the liquid is dripping from the cylinder. And then you found dv dh. dv dh was what we found the other time to be 30.25 pi meter squared times dh dt, which we are actually looking for. So it means the h dt will simply be minus 0.2 meter cube per second divided by 30.25 meter squared. And that's what you have here. So minus 0.2 meter cube per second divided by 30.25 pi meter squared. Meter squared will cancel 2 of the meter here. So you're going to end up having minus 0.2 divided by 30.25. That is minus 0.0021 meter, this meter per second now. So that means that the depth of the water is reducing by 0.0021 meter per second. So as such, the depth of the water in the tank is decreasing at the rate of 0.0021 meter per second. So with this, again, I've come to the end of this video talking about rate of change. So in this case, you discover that you have to apply formulas based on the context you're given. So if you're told something has the shape of a pyramid or triangle or something, you need to find the formulas associated. So don't forget to subscribe and hit the bell button so you can always get notifications when a new video comes. See you in the last part of differentiation, applications of differentiation, which talks about stationary points or turning points or maximum points or extreme points and things like that. See you then.